turned into sedimentary rocks by the process of diagenesis, an important component of diagenesis is the process known as lithification. The term lithification then is used to describe those processes that result in the fragments of pre-existing rock getting stuck together. And those processes include compaction, cementation, and recrystallization. Those are typically the three component parts of the process known as lithification. Now, obviously, in the case of those sedimentary rocks that form by precipitation out of solution, by virtue of that process, they're stuck together from the get-go, as it were. They don't have to be as concerned with this process as the compaction, cementation, and recrystallization. Compaction, when you think about it, is a logical process. You've got sediment accumulating in the Mississippi Delta, for example. At the time of deposition, you might have porosities on the order, particularly in finer grained sediment like silts and clays. You may have porosities on the order of 50, 60, 70%. Well, what happens is, as you add more sediment on top of that pile, you generate what's known as a sediment load, and obviously it squeezes that on which it's sitting, and when it squeezes it, it compacts the solid particles and it expels water and reduces the pore space that was originally developed at the time of deposition. So there's your compaction. The cementation obviously relates to the interstitial fluids that exist between the individual particles. If those fluids become saturated with respect to, say, calcium carbonate, the calcium carbonate can precipitate out of solution, and when it does so, it precipitates onto the surface of the grains or particles and then binds them together, the cementation process. Recrystallization is a somewhat more complex component of lithification and tends to occur after the sediment has been buried to some significant depth, and the pressures involved in the contacts, grain-to-grain contacts, get to be high enough that you can get actual kind of welding together of the grains by recrystallization. And in the process of lithification, there's no necessarily initially defined sequence. In other words, you don't have to have compaction to make a sedimentary rock. If you cement them up early enough, in other words, close to the sediment-water interface, which happens quite commonly with carbonate rocks, for example, they don't undergo necessarily a great deal of compaction because they have a tendency to cement up pretty early in their history. So the three components of lithification can kick in a variety of orders and in a variety of time frames. So the products of mechanical weathering tend to generate the particles, the solid materials that get transported and deposited and ultimately get turned into sedimentary rock. The products of chemical weathering involve obviously putting materials into solution, and those materials are equally then transported by groundwater, streams or rivers or what have you to different locations until such time as the concentration of those materials in those solutions reaches a concentration under the right sets of pressure temperature conditions that will result in precipitation either as cements to bind together the fragments of pre-existing rock, or as minerals that form sedimentary rocks in their own right of the precipitation variety, as it were. So if we look at sedimentary rocks, we can think of them in terms of their origin, in terms of a cycle, or again part of the rock cycle. We start out with weathering, and this is the process by which Mother Nature attacks existing rocks and breaks them down into either solid or dissolved components. Erosion then is the process by which the particles, talking about the particulate solid material, are entrained or picked up by some mechanism, current. The current could be a wind current or a water current in a stream or river. So the weathering process generates these particles which are broken down by a variety of means. Erosion is the process by which they are picked up or entrained, and then they go into transportation mode, and those particles are transported, if we use a stream or a river as our example here, they are transported either in suspension or in what's known as bed load, where they roll or bounce along the bottom of the stream. And then ultimately, these sediments will accumulate at some endpoint, presumably in a basin of deposition. So think of in a simple-minded picture of the Mississippi River and the Gulf of Mexico. The Gulf of Mexico is the hole in the ground where the sediment accumulates. The river is the means by which that material is brought to the hole in the ground. And it's important to think of the sedimentary process in a very simplistic fashion, where you have high points and low points. The high points tend to be the source of the sedimentary material that will ultimately give rise to sedimentary rock. The low point, what we would refer to as a sedimentary basin, is where the sediment accumulates through the process of deposition. And then finally, you have diagenesis, the last kind of component. And this refers to all of those things that happen to sediment after it's accumulated in the sedimentary basin. And the things, as it were, that affect the sediments in the basin can be mechanical, bioturbation, for example, organisms that eat their way and chew their way through the sediment, that is affecting the sediment after burial. Lithification that we talked about, where things get stuck together, and after they become lithified into the form of rocks, any passage of groundwater fluids through those rocks can alter the package as it sits there by either dissolving and or precipitating materials out. Do you have a question? Under what? A marine environment. Okay. Well, the transportation, if we use the Mississippi River as an example, as a means of transportation, it dumps the sediment in a marine environment. Okay? And that's an interesting point. Sediments can accumulate and be deposited in freshwater environments, in lakes and in rivers. They can be deposited in continental environments. Sand dunes in deserts would be an example. Or, of course, they can be deposited in marine basins, the Mississippi Delta building out into the marine Gulf of Mexico, obviously. So the environments of deposition in which the sediment can accumulate is highly variable. Okay? So if we look at sedimentary rock types, there are fundamentally two. I mean, when you read textbooks and in the literature, you might see three listed because sometimes people will break out chemical and biochemical rocks into separate categories. But basically what we've been talking about so far this afternoon is about ferruginous and chemical/biogenic or biochemical sedimentary rocks. And the point about ferruginous sedimentary rocks is that they exhibit a particular kind of texture referred to as a clastic texture. Clastic comes etymologically from the Greek klastos, meaning fragment. And if you think about the definition of a ferruginous sedimentary rock, an aggregate of fragments of pre-existing rock, that describes the textural aspects of ferruginous rocks. You can see individual fragments that have been transported independently, brought together, and through the process of liquefaction